Yeah, greetings of the day. Myself, K.Sathish, working as Assistant Professor in CSE Department, MITS deemed to be University. Today I am going to deliver a topic on deadlocks in operating systems. So deadlock is very important topic in operating system. So these are all the presentation content of the deadlock. Introduction, then conditions for deadlock, methods for handling of deadlocks, examples of deadlock and their handling methods. Finally, I will conclude the summary of the deadlocks. So deadlock is nothing but deadlock is a situation where two or more processes are unable to proceed because each process is waiting for the other to release a resource. So this will create a cycle of dependencies that leads to a permanent state of inaction. So normally deadlock will occur in multi-threading application and multi-processing environments. Particularly, deadlocks will be dealing with shared resources. So this figure shows the examples of deadlock. P1 holds, suppose process P1 holds resource R1 and requesting R2. In the meanwhile, process P3 holds resource R2 and requesting R1. Both process is in uh, both processes in waiting state only. Process P1 and P3. No progress can be made. So this situation we can call it as a deadlock. Examples of deadlock: consider two processes P1 and P2. Process P1 locks resource A and waits for resource B. Process P2 locks resource B and waits for resource A. Neither process can proceed. This situation will be resulting in a deadlock. Both process P1 and P2 cannot able to complete their process. Both are in waiting state only. This situation we can call it as a deadlock. Why means process P1 waiting for the resource B and process P2 waiting for the resource A. But P1 is locking the resource A and P2 locking the resource B. This both process P1 and P2 will be in waiting state only. So this situation we can call it as a deadlock. Suppose another real-time examples of deadlock. Imagine two cars approaching in a single lane bridge from opposite directions. Suppose car A enters the bridge from one side, car B enters from the other side. Neither car can move forward because the bridge is occupied. Neither car can move backward because there is a traffic behind them. So this situation creates a deadlock. This figure shows the examples of deadlock, the real-time examples of a deadlock. Like car A will be traffic behind a car A and car B traffic behind car B. So car A enters the bridge from one side and car B enters the from other side. Neither car can move forward. The bridge is occupied. Neither car can move backward. The traffic behind them. So both car A and car B in deadlock situation. And next coming to conditions for deadlock or Kaufman conditions. Deadlock occurs if the following four conditions hold simultaneously. The first one is mutual exclusion, second one is hold and wait, and third one is no preemption, and the fourth one is circular wait. Mutual exclusion means only one process can a resource at a time. Here resources cannot be shared. Coming to hold and wait, a process holding a resource is waiting for additional resources which is held by other processes. Coming to no preemption, a resource cannot be forcibly taken from a process, it must be released voluntarily. This is about no preemption. Coming to circular wait, a circular chain of two or more processes exist where each process is waiting for a resource which is held by the next process in the chain. These four condition is very much important in a deadlock. The necessary conditions the necessary conditions for the deadlock, four condition must these for the following four condition must hold simultaneously. The first one is mutual exclusion. Suppose a printer can only print one document at a time. Here resources cannot be shared. Hold and wait. Normally telephone call also, like when we are making a call to another persons, if emergency calls, now we are keeping the call in hold. At that time we are in waiting state, so we cannot talk uh, parallelly. So this situation is call it as a hold and wait. Another example for this hold and wait: a process has locked a file and is waiting for access to a database. One process is locked a file, we cannot access the data that file or accessing a database because that process has locked. Hold and wait. Coming to no preemption, a process using a CPU cannot be stopped voluntarily, okay, until it can be completes until that process releases. We can we can release. Then coming to circular wait, process P1 holds resource R1 and waits for R2. P2 holds resource R2 and waits for R3. Process P3 holds R3 and waits for R1. This will create a circular dependency. All the process P1 and P2, P3 cannot complete their task. So P1 is waiting for R2, P2 is waiting for R3, P3 is waiting for R1. So this situation we can call it as circular wait. This will leads to a deadlock. The next, coming to methods for handling of deadlock, there are three methods for handling of deadlocks. One is deadlock prevention, another one is deadlock avoidance, and the next one is deadlock detection and recovery. Coming to deadlock prevention, by ensuring at least one of the necessary conditions for deadlock cannot hold, the mutual exclusion will be we can prevent any one of the conditions, at least any one of the condition we can prevent the deadlock, either mutual exclusion, hold and wait, no preemption, circular wait. Coming to deadlock avoidance, this is very much important in deadlock to ensure the system never enters a deadlock state. So we have the two methods for avoiding the deadlock. One is Banker's algorithm. The Banker's algorithm which ensures resource allocations leaves the system in a safe state. And one more is resource allocation graph. These are the two methods for avoiding the deadlock. In Banker's algorithm law, we have safety algorithm and resource request algorithm. First, we have to check resource request algorithm. The requested process is permission is safely granted or not. Once the permission is granted, then we can go for the safety algorithm. In safety algorithm, to find out whether the system is in safe state or unsafe state. To find, we have to find the sequence. With this, we can avoid deadlocks. These are the two methods for avoiding the deadlocks. One is Banker's algorithm, another one is resource allocation graph. And the third method is deadlock detection and recovery. A deadlock to occur, we can detect and resolve the deadlock when they need. So here also we have the two methods for deadlock detection algorithm. Wait for graph, a single instance of each resource type. Then the next method is multiple instance of each resource type. With these two methods, we can detect the deadlock and we can recover the deadlock by using this process termination and resource preemption method. Process termination means kill or to break the deadlock. Resource preemption means while executing the process, temporarily we can take the resources away from some processes. These are the examples of deadlocks, some real-time examples. First method is deadlock prevention, ensuring at least one of the deadlock conditions never occurs. Example, if you take an example, database transactions, if you take an banking transaction, a bank system prevents deadlock by ensuring transactions acquire locks in a predefined order. How to prevent means this will avoid circular waits by enforcing a strict resource request order. For example, always lock account A before account B. The second method is deadlock avoidance. Some real-time examples for deadlock avoidance method. Air traffic control. Air traffic control method that multiple planes do not enter a deadlock state by pre-allocating runways before allowing landing request. How to avoid means the system which ensures that there is always a safe sequence, which means where at least one aircraft can land and clear the runway. Using additional information to prevent unsafe resource allocation. The third method is deadlock detection and recovery. The real-time examples for this operating system process scheduling. Scheduling means determines the order in which processes are executed by the CPU. In a multi-threaded operating system, two processes may be waiting for resources held by each other. One process waits for a printer while another waits for a file lock. So the how to detect and how to recovery. The operating system monitors the resource allocation graphs for cycle and detect the deadlocks. Recovery. The operating system may terminate one of the processes or preempt a resource to resolve the deadlocks. So this is I will conclude this. Deadlock is a situation where two or more processes are permanently blocked because each process is waiting for a resource held by another process. There are four conditions we have seen. Kaufman conditions: mutual exclusion, hold and wait, no preemption, circular wait. And methods for handling of deadlocks we have seen, like deadlock avoidance, deadlock prevention, deadlock detection and recovery. Deadlock prevention means eliminate one of the deadlock conditions. We can prevent the deadlock. Avoidance means we have two methods. Uh, by using the algorithm, we can avoid the deadlock: Banker's algorithm, safety algorithm, as well as resource request algorithm, as well as resource allocation graph. Deadlock detection and recovery. We have to detect the deadlock. We have to find the deadlock where it is. Then we can resolve the deadlock by using the methods called single instance of each resource type and multiple instance of each resource type. Finally, deadlocks which reduces system performance can halt process execution. Therefore, this technique is very much important. Deadlock prevention, avoidance and detection and recovery techniques, which is essential for efficient operating system resource management. With this, I will conclude. I hope this will be useful. Thank you.